All right, so this was a calculator free response question, just like the type of question we will get on Thursday. Okay, so look through this. This is going to be a lot of points. Try to keep score for yourself as you work through it. A particle moves along the x-axis. They gave me velocity. They told me that the particle at position x equals -5 at t equals 0. So this is my starting position. That's the reason why they gave me this to me. That's my start. Find the acceleration of the particle at time t equals 3. What do I need to do in my calculator to find acceleration given velocity? Take the derivative. You scored 1 point on this question. If you just wrote v prime of 3 or a of 3 equals that number, -2.118. That's all you had to do. You scored 1 point. There wasn't a whole lot of work to show. Questions on the first one? Just math 8 in your calculator is all you need to do. Okay. Part B, find the position of the particle at t equals 3. If I'm finding the position, if I integrate velocity, if I do this, what is this right here going to tell me? That is the change in position. Not the position, but the change in position. That's the displacement. I need to add to the change in position whatever my starting position was. So we started at -5, so -5 plus that will give me my answer. Okay, so here's how the point breakdown happened. You scored 1 point if you integrated from 0 to 3. If you found the change, if you found that displacement, that scored you 1 point. You got a second point if you used the initial condition, if you used the idea that you started at -5. So if you have -5 written down somewhere, that scored you a point. And then you scored your last point for getting the right answer by typing into your calculator -1.760. So you should have scored 2 points, even if you didn't know it was a calculator question, because you could have written the first part out. Questions on B. Part C. Evaluate this guy. Plug it into your calculator, hit enter. Evaluate this guy. Plug it into your calculator, hit enter. That's all it's asking you to do. And then interpret the meaning of each. This was, as I walked around, this is what we struggled with. Okay? The first point was easy. It was typing in your calculator. The stuff in green scores you 1 total point. Okay? The stuff in yellow is going to score you 1 point. The integral of this right here is the displacement or the change in position. You have to state your time. That was something we missed on our last test and what I saw the most missed as I walked around. It is not just change in position, but change in position from 0 to 3.5 because that's what the bounds mean. Okay, same thing on the blue one. When we integrate with absolute value, now that's the total distance traveled during that time interval from 0 to 3.5. So 1 point for the yellow, 1 point for the blue. Questions there? The last one. Okay, a second particle moves along the x-axis given by x sub 2t. I don't like that they do this, but it's just what they're calling the second equation position. Okay, the second position equation. We want to know when the two particles have the same velocity. If I want to know when they have the same velocity, I better talk about velocity. They gave me the initial velocity. I quickly found the second equation's velocity because I just took the derivative. Okay, so I scored 1 point. If you wrote what the second equation's velocity was, so if you set 2t minus 1, okay, they want you to set them equal to each other. So they want to see the velocity of the initial equation is equal to 2t minus 1, because that's what you want. You want to know when the two velocities are equal. So if you take the two of them and set them equal to each other, that would have given your answer. The time that happened was 1.507054. Okay, 3 decimals, 1.571. You scored 1 point if you showed that you set them equal to each other, and then 1 point for your answer. I'm guessing you're more likely to have the answer than the other one, but make sure you're showing that on your paper what you did. Add them up. Go through. How did you score out of 9? What did you score on that guy? Show me with your fingers. How'd you do? A lot of 6s, 3s, 4s, 5s. I don't care. Okay, but if you're at a 6, I'm guessing a lot of that, what did we forget? The units and the time intervals is what I meant. Time intervals, and then which one? The last one to set them equal. Okay. So you know what you're doing here. Okay. If you're scoring a 6, that's really good. Again, remember on the AP exam, you're trying to get that 4. If you're at a 4, you're doing excellent. Okay. So a 6 is really excellent. We're going to try to keep getting above a 6. And on this question right here, you want to get a 9. Okay. There is nothing in there that you can't do. We want to get to the point where we're getting a 9 on that. And again, we're going to go over that on Thursday, sorry. Let's go to Desmos, see how we did. This was bell work on Desmos. The function f is defined on that interval. Okay, a whole bunch of stuff is given. This is a graph of f. Let g be the function defined by the integral from -1 to x. Find the x-coordinate of each point of inflection of g. Okay, so the key to this is g is the antiderivative of f. Show me with your fingers. How many points of inflection are there? Show me with your fingers. How many points of inflection are there on this graph? There are 2. Okay. Let's look at these answers. This is a free response question. This would be worth 2 points on the AP exam. Let's see how you would have done. Okay. This first person, they included -5. Remember, we never care about endpoints when we talk about points of inflection. Points of inflection do not happen at endpoints. It's been up there the whole time. Okay. We look at this one. Man, that one's pretty close. I don't love how that's worded, but yeah, I think you're getting full credit for that. Where does it happen at -3 and 0? Why? Because extrema are on that graph of G prime and F equals G prime. That's fine, actually. I don't dislike it. This spot right here, -3 and 0. Those are the 2 places we care about. Why? Because it has extrema. Points of inflection happen when the derivative has extrema. This is a derivative. Okay. Notice that they linked F and G prime. Okay. This one right here, probably not enough because relative extrema. Well, what has relative extrema? You need to finish that sentence. Okay. Good. I'm liking that everybody has a link. Like this person right here, x equals 0. They're missing a number, but they're not going to get full credit because they don't have that link. What is G prime? You can't just talk about G prime without telling me what G prime is. Okay. Down here, now we're starting to get, again, here. Like that one is great, but there's no link. We got to link F equals G prime. Does that make sense what you need in order to get credit there? Okay. The derivative has to have relative extrema. That's the kind of elements we need. Questions? What you're doing on Desmos, you've got this activity. You are going to work through them. So you've got a question here. Sorry, wrong ones. You're looking at one of these questions. The problem is right there. You're going to work through that question. You're going to find the multiple choice answer that matches it. You click the answer, and then you move to the next slide. Okay, you've got 6 questions here on the first half. I'm going to give you a little bit of time. You can use that paper to write stuff down. On this paper, I at least want you to write down what you would need to get full credit on the free response portion. Okay, so if this is a free response question, what would I need? That way when we check them in a minute, you can see, oh, I had enough, or no, I didn't. Okay, that's what you're working on. You're working at your own pace. Call me over when you need me. We'll see what you can do. Go.